Hi guys, welcome to this week's first lesson. So this week we're talking about rational functions still, and we're talking about horizontal asymptotes or oblique asymptotes. So we've already talked about domain with rational functions, vertical asymptotes, and holes. This is the next step to being able to graph them, which is horizontal asymptotes or slant asymptotes, which is another word for oblique asymptotes. We're going to do a few definitions first. And then we're going to do quite a bit of definitions first to before we get on to the work. So that's mostly what the first couple pages are, just definitions and examples. So here we go. A horizontal asymptote, or HA, is we're going to abbreviate it, shows left-end behavior of the graph as x goes to negative infinity, and the right end behavior, or as x goes to positive infinity. So I'm just going to pause really quick. I want to make a quick note about this first part. We talked about end behavior when we were doing polynomials. Next year, when you guys go to calculus, for those of you who are doing calculus, or either next year or the years after when you're in college, what you're talking about when you're talking about end behavior in calculus, they're going to ask you about the limit. And that's basically what's the value when you get out to infinity or negative infinity. What's the limit of that function? What are you going to? So they're kind of hand in hand. I just want you to kind of think about that when that comes up next year, the year after, whenever you get to calculus or pre-calculus. So the next part of our definition says every rational function has one horizontal or oblique asymptote. And I spelled it wrong. T-O asymptote. Okay. So note the vertical asymptote cannot be crossed. Remember I said the definition of an asymptote is a line that the graph approaches but doesn't cross. That's true for the vertical asymptote, while the horizontal asymptote can be crossed. So it can go below or above the horizontal asymptote and approach from either the top or the bottom. So that is cannot be crossed is true for vertical but not for horizontal, just to let you know that. So how can they be determined? So how can a horizontal asymptote be determined? There are three cases. Okay, depending on the relationship between the degrees of the polynomial in the numerator and the one in the denominator. So we're looking at the degrees, and remember degrees is the highest power on the variable in each one. So there's three different cases, and I'm just gonna describe them right now so you know, and tell you what it looks like. So if and I'm going to tell you what n and m is in just one moment. Okay. Well, let's do it here. So in my degree of my numerator is going to be my n, and my degree of my denominator is going to be my m. So you know the difference here. So case number one is if n is less than m. That means my numerator has a smaller degree than my denominator. Then my horizontal asymptote is going to be y equals 0. Pretty easy, okay? The second case is if they equal each other. If not m, if n equals m. If I have the same degree on top and the same degree on bottom, my horizontal asymptote will be y equals a sub n over b sub m. And that's where a sub n and b sub m are the leading coefficients of the numerator and denominator, okay, respectively, okay? The n goes with the numerator, the m goes with the denominator. And then the third case is if n is greater than m, so my numerator, the degree of my numerator is bigger than the degree of my denominator. And then my horizontal asymptote is none. I don't have a horizontal asymptote. What I have, however, the graph has an oblique or slant asymptote. Okay, so now I'm going to talk more about each case individually and show you what an example for each one. So here we go for case 1. Case 1 is where n is less than m. Okay, so I'm looking at the degree. Well, the degree of my numerator is right here. I have x. X is my only variable, and it doesn't have a power. So that means it's degree 1. Okay? So if I look at my denominator and I multiply them together, x times x is x squared, which means my degree is 2. That gives me an m of 2. Okay, so I have to multiply. If I'm finding my degree, I want to make sure they're multiplied together. Okay, so that gives me my degree. That tells me that 1 is less than 2. So n is less than m. That gives me, in case 1, if n is less than m, it tells me my horizontal asymptote is y equals 0. So on my graph, what I would do is I would draw a dotted line at y equals 0, which is right here. Okay, notice my graph here doesn't go below or above. It's not touching the line, it's approaching it, which is okay, right? That's acceptable. So the next one we're going to look at is case 2. Okay. So case 2 says n equals m. Okay, so again, I want to find my my degree. So the numerator, it's 2. So n is 2, n for numerator. Again, I got to multiply the denominator out. So x times x is x squared. So I get a degree of 2. So for my denominator, m is 2, so they equal each other, right? We know that they equal each other. So case 2 says, if I remember, if I'm looking, case 2 says my horizontal asymptote equals a sub m over b sub m. That's my leading coefficient. So if I look at the leading coefficient, that's the number with the variable. So here is a 3. That's a sub m. So a sub m equals 3. Oh, a sub n, sorry. A sub n equals 3. And b sub m is the number with my variable here, which is, there isn't one, but I still have a variable. So how many x squareds do I have? 1. So that leaves me to my y-intercept, my horizontal horizontal asymptote being 3 over 1 or 3. And if you look on my graph, they've put it right here at 3. Okay, and then remember I told you that sometimes the graph goes below it, and that's why we have to kind of test when we're graph. We'll get to that, but when we graph, we kind of have to test the spots. And if you look, this graph does not go below, so it's going to be above, and then this time it goes below, and then it's approaching 3 from below. So you'll have one line that approaches from above and one line that approaches from below. We'll get to that when we start graphing. Right now we're just trying to find where those lines are and what they are. So don't freak out about that quite yet. Okay, and then we have the third case. And the third case is with when n is greater than m. So again, I'm looking for the degree. So the degree of this one is 2. Oh, and I put 3. See, I knew something was wrong. So the degree of that is 2. And the degree of the bottom is 1. Okay. So that means that 2 is greater than 1. That means I don't have a horizontal asymptote. I have a slant asymptote. Okay. And how do I find a slant asymptote? That's the question. This is the hardest part. I'm not going to lie to you. This is the hardest one. So to find a slant asymptote, I'm going to divide the polynomial in the numerator by the polynomial in the denominator. So I'm going to use long or synthetic division. So I'm going to have to use some of those skills that I learned when we were doing polynomials, long division or synthetic division, and the quotient gives us the asymptote, the equation of the asymptote. So here, look, here's my equation oh my goodness, I can't even talk right now, so sorry. So we did synthetic division, as you can tell. I took my coefficients, which are 3, -2, and 1, right? 3, -2, and 1, and I divided by x minus 1 equals 0. I need to find out what x equals, so plus 1 plus 1. So x equals 1, so I divided by 1. Okay, remember you bring the 3 down, then multiply 1 times 3 is 3, add it together, you get 1. 1 times 1 is 1, add it together is 2. So now this is the important part. So when we're doing the synthetic division, remember I take this one down 1. If my original one was x squared, it's going to be 3x. So this is y equals 3x plus 1. I know I have a remainder. In my equation, the remainder doesn't matter. I don't care about the equation. I only care about the ones that are going to give me the equation. I know it's a little weird, but that's what it is. And then it's a line. Y equals mx plus b. I graph it right here. Now I want you to be aware of the fact that sometimes I might not get a line. I may end up with a quadratic. I may end up with a cubic. Okay, so sometimes you end up with some weird stuff, but once I do the synthetic division or long division, whichever one it is, whichever one you like, and I am going to put in some videos for synthetic division and long division. I'll put in one video for each in the Canvas, so if you can't remember how to do it, it's in there, so you can look at it, okay, and refresh your memory on how to do that. But then that's the answer. That's it, done. Okay. Here we go. So now we're just gonna practice them. We're just gonna practice it. We're gonna do the work. Okay. So I have 3 cases. The first thing I need to do, 1, find the degrees. Okay, I want to find the degree of num and denom. So of my numerator and my denominator. So the degree of my numerator, or n equals 1. And then the degree of my denominator, it's a variable by itself, m equals 1. And then I know from that 1 equals 1. So I know that m equals n. Oops, I wrote it the wrong direction. I know, got to write it the right direction, so sorry. N equals m. I'm used to writing things in alphabetical order, but in this case, all the n's always come first. Whatever's in the top comes before what's in the bottom. So from that, if we look back at my rules, what does that tell me? Well, let's see. If n is, let's see if I can remember what them are off the top of my head. I'm going to cheat and look back at my notes. If n is less than m, that tells me that y equals 0. And if n equals m, that tells me that y equals a sub n over b sub m. And if n is greater than m, that tells me that there's a slant asymptote. Okay? So those are my rules. So since m equals n, I need to find a sub n, and b sub m. So a sub n is the coefficient in the numerator, so that equals 3. And b sub m is the coefficient in the denominator, which is 2. So y equals 3 over 2. And that's your answer done. Okay? That's all. Okay, let's go to the second one. We're still going to do the same thing. We're going to find the degrees. So, oh, sorry. Let's go here. So n equals 3. And m equals 1. So then we know that 3 is greater than 1. Okay, so that means that n is greater than m. So I have a slant. That means I need to divide. So I'm going to divide. I'm going to take negative 2x cubed plus 0x squared minus 2x plus 0, and I'm going to divide it by x minus 4. Okay? And I can do long division or I can do synthetic division. And since this is just x minus 4, it's to the first degree, I'm going to do synthetic because it's quicker and easier. So I'm going to take my coefficients, which are negative 2, 0, negative 2, and 0. And I'm dividing by positive 4. Remember, I don't want x minus 4. I want to know what x equals. So that would be 4. So I'm going to bring down my negative 2 and then multiply, and I get negative 8. Add it together, and I get negative 8. Multiply 4 times negative 8 is negative 32, and that gives me negative 34. Negative 34 times 4. 34 times 4. Negative 136. Add that together, negative 136. Got an extra 6 in there somehow. Okay, so I get y equals, and it's x cubed, so I'm going to go down 1. Negative 2x squared minus 8x minus 34. Don't need the remainder. And there's my equation for my asymptote. It's a quadratic. It's okay. Can have a quadratic. Okay, that's all I need right now. I'm not graphing it. I'm just finding the equation of the line. Okay, on to the next one. Here we go. What is my degree in my... What's the degree in my numerator? Well, there we go. N is, there's no variable in my numerator, so no means n is 0. And I have to multiply x times x, and I get x squared. So my degree in my denominator, or m, is 2. So that means that 0 is less than 2, right? So let's go up to my rules here. Less than 2 right here. If it's less than, it means my horizontal asymptote. So n is less than m, so my horizontal asymptote is y equals 0. Done. Okay, there you go. You have some examples to work on, and then you have a Delta Math assignment. If you have any questions, please give me a call or one of your teachers a call. We'll be glad to help you out. Thank you and have a great night. We'll see you in the next lesson. Bye.